Hello there, and welcome to the Sleepy Science Secrets. Tonight, we are going to drift into one of the most quietly astonishing secrets about the world beneath you. Right now, as you breathe slowly and settle into your pillow, you are hurtling through space at speeds that would leave any wind breathless. And yet, you feel nothing, not even a whisper of movement. The ground beneath you is still, the air around you is calm, and somehow the planet carrying you is spinning through the dark at over 1,000 miles per hour, while also orbiting the sun at nearly 67,000 miles per hour. And none of it reaches you. No rumble, no vibration, no sense of speed at all. Tonight, we will wander together through the beautiful, strange science of why this is so. Let your body grow heavy, let your eyes soften, and let the wonder carry you gently toward sleep. The earth is spinning right now. At this very moment, as you breathe in and breathe out, the ground beneath you is rotating from west to east. It completes one full turn every 24 hours. At the equator, that spin works out to about 1,670 kilometers per hour, a speed that, in any other context, would feel extraordinary. And yet, you feel nothing. There is no wind rushing past your window, no sensation of leaning, no hum you can hear. The reason for this is one of the softest, most elegant truths in all of physics. You are not being left behind by the Earth's rotation. You are part of it. Every cell of your body, every gram of the air around you, every leaf on the tree outside, all of it moves together all at once in perfect company. There is nothing to push against, and so there is nothing to feel. This idea has a name, though the name itself is less important than the feeling it describes. Scientists call it inertia, the tendency of things to keep doing what they are already doing. If you are sitting still, inertia keeps you still. If you are already moving at the same speed as everything around you, inertia makes that movement feel like stillness. You were born into a world already spinning, and you have been spinning with it every moment of your life. Your body never had to learn to feel it, because from the very beginning, it was simply home. There is something almost tender about that. The earth did not ask you to hold on. It simply carried you quietly from the very first breath. And it is still carrying you now, this moment, as your eyes grow softer and the room around you settles into its nighttime quiet. You are never standing still, not really, but you are always held. The motion is there, enormous and ancient, but so gentle in its constancy that it has become invisible, the way the sound of your own breathing fades when you stop listening for it. Imagine standing on a very large, very smooth ship. The ship is moving across a calm sea at a steady speed. You're inside, and the windows are covered. You cannot see the water passing. You cannot feel the engine. It is too smooth, too constant. If someone asked you whether the ship was moving, you might say you weren't sure. You might even say no. This is exactly the situation you live in every day. The earth is your ship. The universe is your ocean. And you have been at sea your entire life without ever quite noticing. The person who gave this idea its deepest early form was Galileo Galilei, a man who loved to watch things fall and swing and slide. He understood in the 1600s that motion only becomes noticeable when something changes, when you speed up slow down, or turn. A perfectly constant movement shared by everything around you is indistinguishable from rest. This was one of the first great gifts of early science. The realization that what we feel is not motion itself, but the change in motion. Galileo called it a thought experiment. You might call it a lullaby the universe has been singing all along. If you like what you're hearing tonight, you might enjoy the other stories on this channel. There's a whole playlist waiting for you, full of gentle science and quiet wonders just like this one. You can find it linked nearby. But for now, let's keep wandering. Your inner ear is, in many ways, the hero of this story. Tucked deep inside your head, behind the soft cartilage of your outer ear, there is a tiny, exquisite system of fluid-filled chambers and canals. These are the structures that tell your brain whether you are moving, not through thought, not through sight, but through the direct physical sensation of fluid shifting. When you tilt your head, the fluid moves. When you spin around, the fluid swirls. The hair-like cells lining these chambers sense the movement, and they send a quiet signal upward. Here is what is happening. Here is which way is down. But this inner ear, as sensitive and lovely as it is, was never designed to feel the slow, majestic rotation of a planet. It detects changes, not constants. If you spin a cup of tea fast enough and then hold it perfectly still, the tea eventually settles. And after that, you would have no way of knowing whether the cup was moving at a steady pace or sitting on a table. Your inner ear works exactly the same way. The Earth's spin is too slow, too constant, too smoothly integrated into every moment of your existence. There is no starting point for the fluid to respond to. There is no moment of change. And so, the tiny chambers stay quiet, the hair cells remain still, and you feel nothing at all. This is worth sitting with for a moment. Your body is one of the most sensitive instruments on Earth. You can feel a single hair on your arm move in a light breeze. You can sense a change in temperature of less than 1 degree. You can hear sounds so faint they are almost imaginary. And yet, a spinning planet beneath you leaves no trace, not because your body is limited, but because this is exactly how physics works. Because the Earth is so consistent, so total, so all-encompassing in its motion that it produces no sensation at all. Sensitivity requires contrast. Wonder requires a threshold to cross. The Earth's spin is simply too much a part of you to be noticed. Think of how you cannot feel the weight of the air on your skin. The atmosphere presses down on every square centimeter of your body with the weight of about 10 newtons, roughly the weight of a small apple. That is a great deal of pressure when you think about it. But because it pushes equally from all sides, and because your body has always lived inside it, you never feel it as weight. You feel it only when something changes, when you climb a mountain and the pressure drops, or when you descend in a plane and your ears adjust. Constancy becomes invisibility. The Earth's spin is the same kind of invisible. Scientists who study the body's sense of balance have a term for the level of change required before a sensation can be detected. They call it the threshold of perception. Below a certain rate of rotation, even the most careful, attentive human body will feel nothing at all. The Earth rotates at about 0.0042 degrees per second at the equator. The human vestibular threshold for detecting rotation is somewhere around 0.2 to 2 degrees per second. depending on the person, the direction, the circumstances. The Earth's rotation is so far below that threshold that it might as well be stillness. You could not feel it even if you tried. And here is something quietly beautiful. The sun is also moving. The entire solar system, the sun, the planets, all the moons and asteroids and comets, is orbiting the center of the Milky Way galaxy. This journey is even slower and vaster than the Earth's spin. It takes the solar system about 225 million years to complete one full orbit around the galactic center. Scientists have a name for that unit of time: the cosmic year, or the galactic year. The last time the solar system was in this same position in its orbit around the galaxy, the dinosaurs had not yet appeared on Earth. And through all of that unimaginable time, the movement left no trace in any living body, because it was always too constant, too shared, too complete. If you're drifting off and want to revisit any of these ideas tomorrow, don't forget to like this video. It helps other sleepy minds find their way here, and it means the world to us. There is a concept in physics called a reference frame. It is, in essence, the platform from which you are doing your observing. If you are standing on the ground is your reference frame. From that frame, everything makes sense. The sky above, the horizon level, the sense of stillness underfoot. But if you could somehow step outside the Earth and watch from space, your reference frame would shift entirely. Suddenly, you would see the planet turning. You would see the blue curve of the atmosphere. You would see the shadow of night sweeping across the surface as the Terminator line. That soft boundary between daylight and dark moved slowly across deserts and oceans and sleeping cities. From out there, the spin is unmistakable. But you are not out there. You are here, inside the reference frame that has always been home. And from inside this frame, the motion is as invisible as the turning of a second hand when you are not watching the clock. This is not an illusion, exactly. It is simply a matter of perspective. Both things are true at once. You are perfectly still in your own experience, and you are spinning through space at extraordinary speed. Physics does not ask you to choose between these truths. It holds them both, gently, the way night holds both stars and silence. There is a small but beautiful experiment you can do if you ever find yourself awake in the small hours and curious about the sky. Go outside if the night is clear and lie on your back on the grass. Watch one particular star. Choose a bright one near the horizon. Lie very still. And if you wait long enough, perhaps 20 or 30 minutes, you will see the star has moved. It will have drifted from where it was when you began. Other stars around it will have moved too, all of them in a slow, majestic arc. They are not moving, of course, not in any meaningful sense. It is you who is moving. It is the Earth rotating beneath you, carrying you in a great slow arc from one angle of sky to another. And in that moment, lying in the grass, looking up, you might feel something that is not quite motion, but is adjacent to it. A soft awareness that the stillness beneath you is not what it seems. This is what astronomers and physicists and curious children have been noticing for as long as there have been stars and questions. The sky is a clock, the sky is a map, and the movement that carries you through it leaves its trace not in your body, but in where the stars have gone. Something else is worth knowing about tonight as you settle in toward sleep. Even though you cannot feel the Earth's rotation, the rotation is not without its effects on you. It shapes the weather patterns that bring rain or sun to your part of the world. It gives rivers in the northern hemisphere a subtle tendency to curve to the right, and rivers in the southern hemisphere a tendency to curve to the left. This is called the Coriolis effect, and it is one of the most graceful fingerprints the Earth's spin leaves on the surface of things. Not on your body, not on your senses, but on the slow, patient movements of air and water across the face of the globe. The Coriolis effect is gentle enough that you cannot see it in a bathtub draining, despite what some people will tell you. That is a myth. The swirl of a draining tub is determined mostly by the shape of the tub and the direction you filled it. But in a hurricane, in a typhoon, in the vast, slow spiral of a weather system stretching hundreds of miles across the sky, the Coriolis effect is unmistakable. The Earth's rotation reaches up into the atmosphere and gives every great storm its characteristic spiral. All that spinning you cannot feel. It has been quietly, patiently at work in the sky above you all your life. As you breathe slowly now, you might like to imagine the air moving above you, high up in the thin, cold layers of the atmosphere. Great rivers of wind called jet streams carry weather systems around the globe. These rivers are shaped in part by the Coriolis effect, by the spin of the Earth nudging the air sideways as it flows. The jet stream over the northern hemisphere flows from west to east, and it makes flights from New York to London faster than flights from London to New York, because the plane traveling east gets a push from the wind beneath the jet stream, while the plane traveling west has to work against it. The Earth's spin is not just under your feet. It is in the sky. It is in the wind. It is in the direction of every great ocean current. It is quietly everywhere. Let yourself sink a little deeper now. Let the mattress hold you, or the cushions, or whatever soft surface has agreed to carry your weight tonight. You do not have to do anything. The Earth is doing the moving. It has been doing it for 4.5 billion years, and it will go on doing it long after every question has found its rest. The moon is involved in all of this as well, in a way that is both strange and soothing. The moon's gravity pulls on the Earth, not just on the oceans, but on the solid rock beneath your feet. The tides we know about, the ones that pull the sea up the beach and then release it again twice a day, are the most visible version of this. But the Earth's crust itself rises and falls by a small amount with every lunar tide, perhaps by as much as 30 centimeters in some places. 30 centimeters is about the length of a school ruler. Twice a day, the rock beneath you breathes a little, pulled upward by the moon, and then settling back. You cannot feel this. It is too slow, too vast, too perfectly smooth to register in the small, warm chambers of your inner ear. But it is happening right now, quietly, as you lie here in the dark. And the moon, for its part, is slowly moving away from the Earth. Each year, it drifts about 3.5 centimeters farther out into space, roughly the rate at which your fingernails grow. This has been happening since the moon was young, and it will continue for a very long time. As the moon moves away, the Earth's rotation gradually slows. Very gradually, about 1.4 milliseconds longer each century. In the deep past, a day on Earth was much shorter, perhaps only 6 hours long when the Earth was newly formed. In the deep future, if the sun allows it, a day might be as long as a month is now. All of this change is too slow to feel, too enormous to register. It happens at the pace of geology, not at the pace of a human life. If you're enjoying this quiet journey through science, leave a comment below. We'd love to know what you're thinking about as you drift off tonight. And remember, there's a whole playlist of stories just like this one, waiting for your next sleepy evening. Speaking of things that are too slow to feel, the continents are moving. Right now, as you rest, the piece of crust beneath you is drifting across the surface of the planet at about the speed your fingernails grow, a few centimeters per year. North America is moving away from Europe. Australia is drifting northward. India has been pushing into Asia for millions of years, and that slow collision is what raised the Himalayas, the tallest mountains on Earth, built not by any dramatic event, but by the patient, imperceptible accumulation of centimeters over millions of years. The ground beneath your home has traveled enormous distances in the history of the Earth. It has been near the equator. It has been near the poles. It has been under shallow seas and buried under glaciers. All of this motion, and none of it ever reached the senses of any creature living on the surface. It was always too slow, always too constant, always below the threshold of what any nervous system could detect. And yet, the evidence is everywhere once you know to look. The rocks of the Appalachian Mountains on the eastern coast of North America are geologically identical to the rocks of the Scottish Highlands across the Atlantic Ocean, because they were once the same mountain range, built when the two continents were joined. The same fossils appear on different continents, separated by thousands of miles of ocean, because those continents were once neighbors. The world you live on has traveled further than any migration, any voyage, any journey in human history. It has simply done so in a silence so deep that no creature ever woke up to notice. There is something almost like compassion in this. The planet does not disturb you with its history. It does not ask you to feel the weight of what it has been through. It carries all of that quietly. The ancient mountains and the vanished seas, the millennia of slow drift. And it offers you a surface that feels, in your small moment upon it, perfectly still. Let your breathing slow down a little more now. There is no hurry. There is nowhere to be. The planet is taking care of the traveling. One of the reasons we cannot feel the Earth's motion is also, in a quiet way, one of the reasons we are here at all. Gravity holds you to the surface of the Earth with a force that is precisely matched to the spin. If the Earth were spinning much faster, the centrifugal tendency, the outward push that comes with rotation, would begin to counteract gravity. If the Earth were spinning much faster at perhaps 17 times its current speed, gravity and centrifugal force would balance exactly at the equator, and a person standing there would feel weightless. They would need to hold on to something just to stay on the surface. But the Earth spins at just the right pace, fast enough to give us our 24-hour day, slow enough to keep gravity firmly in charge. Everything about the way you rest against the Earth tonight is a result of this particular balance. And gravity itself is something worth lingering on for a moment, because it is perhaps the most familiar feeling in your life, so familiar that you almost never notice it either. Gravity is the pull of the Earth's mass toward its center, and you feel it as weight. as the gentle, constant pressure of the ground beneath you. Right now, every part of your body is being drawn downward, and every part of what is holding you up is pushing back. These two forces are exactly balanced, and the result is the sensation of lying still, of being held, of not falling. Gravity is a kind of embrace. The planet is holding you just firmly enough that you feel supported, not crushed. This too is a threshold thing. Below a certain force, we feel supported. Above it, we feel weight. Tonight, you are exactly where you need to be. Now, let's wander into something that might surprise you. Sound. The Earth is not entirely silent. Deep inside, the planet generates a kind of hum, so low, so far below what human ears can hear, that it was only discovered relatively recently, with instruments sensitive enough to detect it. Scientists call it Earth's hum, or sometimes the Earth's free oscillations. It is generated by ocean waves interacting with the seafloor, by the constant movement of atmosphere, by the deep elastic resonance of the rock itself. The frequency of this hum is around 10 millihertz, roughly 10,000 times lower than the lowest note you can hear. But it is there. The planet is vibrating very gently all the time. It has been vibrating since long before any ear existed to not hear it. And you are part of that vibration resting on its surface, a tiny temporary softness on the face of a quietly singing world. The idea that you cannot feel the Earth moving is also a door into something called the equivalence principle, one of the most elegant and important ideas in all of physics. Albert Einstein used it as the foundation of his general theory of relativity. The equivalence principle says that there is no experiment you can do inside a closed box that will tell you whether you are standing still on the surface of a planet or accelerating through empty space at the same rate as the planet's gravity. They feel identical, not similar, identical. The experience of rest and the experience of being perfectly, uniformly carried are the same experience. From inside your room, you cannot tell whether the Earth is beneath you or whether the universe has arranged itself to feel exactly like the Earth is beneath you. This is one of those ideas that sounds strange at first, and then, if you let it settle, begins to feel like something you almost always knew. You might find yourself, as you rest here, thinking about astronauts. In orbit around the Earth, astronauts float. They feel weightless, not because there is no gravity. There is. The Earth's gravity is what keeps them in orbit, but because they are in free fall. They and their spacecraft are falling together at the same rate toward the Earth. And because everything is falling together, there is no sensation of weight. They drift in their cabins. Water floats in globes. Everything is perfectly, gently unmoored. And yet, they are moving at about 28,000 kilometers per hour, circling the Earth once every 90 minutes. Speed without sensation. Motion without feeling. The same principle that keeps you unaware of the Earth's spin keeps the astronaut unaware of their orbital velocity. All that differs is the reference frame. Leave us a like if you're finding this soothing. It really does help others discover these quiet evenings, and we're so glad you're here. There is a thought experiment sometimes used to help people understand the nature of gravity and motion. Imagine you are in an elevator and the cable breaks. The elevator begins to fall. For a moment, a brief, strange moment, you would float. Your feet would leave the floor. Everything around you would become weightless. not because gravity has stopped, but because everything in the elevator is falling at the same rate. And so nothing is pushing against anything else. In that falling elevator, you would feel, briefly, the way astronauts feel in orbit. Then, of course, the elevator would reach the bottom, and the physics would reassert themselves in a much less gentle way. But in that falling moment, in that pure, brief interval of shared acceleration, gravity would vanish from experience, even as it continued to act. This is why Einstein said gravity is not a force so much as a curvature, a shape that space and time take in the presence of mass. When you rest on the earth, you are not being pushed or pulled in the ordinary sense. You are following the shape of space. The earth's mass curves the fabric of space-time around it, and you are simply following the most natural path available to you, which happens to be pressed against the surface. This is not a metaphor. This is, as far as physics can tell, the actual geometry of where you are. You are lying on a curve. The curve is the Earth, and the curve is caused by the presence of a mass so enormous that it bends the very medium through which time flows. That last thought is a big one for a sleepy evening. Let it be big. Let it fill the room gently and then dissolve, the way the last light of evening dissolves into night. You don't need to hold on to it. It will still be true in the morning. Let us talk about time for a moment, because time and motion are more deeply linked than you might imagine. Einstein also discovered that gravity affects the passage of time, and that this is not a strange consequence of the theory, but a central part of it. Time passes more slowly when gravity is stronger. At the surface of the Earth, where gravity is slightly stronger than at the top of a mountain, time moves very slightly more slowly. We are talking about differences so small they can only be measured with the most precise atomic clocks. But they are real. The atoms vibrating in a clock at sea level vibrate ever so slightly more slowly than the atoms in a clock on a mountaintop. If you could live your whole life at sea level, you would age a tiny fraction of a second more slowly than someone who spent the same years at high altitude. GPS satellites orbiting far above the Earth, where gravity is weaker and time passes faster, have to correct for this effect constantly. Without the correction, the satellites' clocks would drift, and the positions they calculated would become less and less accurate over time. The entire global positioning system is a living, orbiting proof of the theory of relativity, and the fact that your phone can tell you where you are within a few meters anywhere on Earth is partly because engineers took seriously the idea that time flows differently in different places. Now, something softer and closer to where you are. Let us think about the horizon. When you look out at the ocean or across a great flat plain, the horizon sits at a certain distance, the point where the Earth's curve takes the land or water out of sight. On a clear day, from a height of about 2 meters, the horizon is roughly 5 kilometers away. That curve is gentle enough that most of the time you cannot see it at all. The Earth simply looks flat, which is why our ancestors were reasonable in assuming it was. It takes a long view, a high vantage point, or a photograph from space to make the curve obvious. And yet, the curve is always there. You are always living on the surface of a sphere, held to it, moving with it, inseparable from it. Something beautiful happens when you internalize this. The horizon is not the edge of the world. It is just the point where the curve takes things away. Beyond every horizon there is more coastline, more mountains, more cities, more sleeping people, all of them resting on the same sphere, all of them as still feeling as you are right now. The earth is a community of stillnesses, each one whole and calm in its own experience, all of them together composing a vast and quiet motion through space. If you haven't already, do check out our playlist. There are stories about the ocean, about light, about the way sound travels, all told in this same slow, gentle way. You can find it linked just nearby. We hope you'll come back. The stars above you tonight have been there for a very long time. The light reaching your window right now, or that would be reaching it if you were looking, left its source years ago. Some of the stars you can see with the naked eye are hundreds of light years away, which means their light has been traveling for hundreds of years just to reach this moment. Some of the stars you see no longer exist. They burned out long ago, but their light is still arriving, still finishing a journey that began before your grandparents were born. You are seeing the past when you look at stars. The sky is a kind of memory, and all of this light has been traveling through a universe that is itself expanding. The space between galaxies is growing, not because the galaxies are moving through space, but because space itself is stretching, like dots drawn on a balloon being inflated. The galaxies are being carried apart by the expansion of the medium they inhabit. This is the largest motion in the universe, and it is perhaps the most invisible of all, because it happens to everything equally in every direction, and so there is no point of reference from which to measure it as movement. In a universe that expands everywhere at once, there is no center, there is no edge, there is no direction that is forward. There is only the stretching, endless and gentle and complete. You are part of this. Resting here, breathing slowly, you are embedded in a universe that has been expanding since the moment of its beginning, nearly 14 billion years ago. Every atom in your body was forged in a star. The hydrogen in your water molecules was created in the first few minutes after the Big Bang. You are made of ancient things, things that have been traveling and transforming for longer than the Earth has existed. And tonight, all of that travels with you as you do the simple, extraordinary thing of resting. You might be wondering, at this soft stage of the evening, whether there is any motion at all that you can feel. And the answer is yes, beautiful, specific kinds. You can feel acceleration. When a car speeds up, when an elevator begins to rise, when a plane lifts off the runway. These are changes in velocity, and changes are exactly what your inner ear is tuned to detect. You can feel rotation if it begins or ends, the dizzy moment when a merry-go-round first starts spinning, or the strange vertigo when it stops and the world seems to continue turning for a moment. You can feel the vibration of sound, the tremor of a distant train, the deep throb of bass notes. Your body is a beautifully calibrated instrument for change. It just is not calibrated for constancy. And the Earth's motion is the most constant thing there is. There is also the pendulum and what it reveals. In the 1850s, a French physicist named Léon Foucault suspended a very long, very heavy pendulum inside the Pantheon in Paris and set it swinging. As it swung back and forth over the course of hours and days, the direction of its swing gradually rotated, not because anyone had pushed it, but because the earth beneath it was rotating. The pendulum kept swinging in the same direction relative to the stars, while the floor of the Pantheon turned slowly beneath it. Visitors who came in the morning would see the pendulum swinging in one direction and return in the afternoon to find it swinging in another. It was the first vivid, undeniable public demonstration that the earth truly does rotate. People stood in the great hall and watched the sand on the floor, placed there so the pendulum could mark its path, and they saw the truth of it. The world was moving, has always been moving, and the quiet proof was a weight on a string swinging in the light. Let your thoughts slow now, the way a pendulum slows when the energy runs out. Let each breath carry you a little further from the day. The earth is moving, the stars are moving, the galaxy is moving, the universe is expanding. And through all of it, you are held in a stillness so complete that you can drift towards sleep as though nothing in the universe were stirring. There is a kind of rest that is deeper than just lying still. It is the rest that comes from understanding that you do not have to manage the motion of the world. You never did. The earth has been handling its own rotation for 4.5 billion years without any assistance from you. The planets have been keeping their orbits. The galaxy has been turning. The universe has been expanding. None of it required your attention or your effort. You arrived in a world already in motion, already perfectly calibrated, already gentle and vast and self-sustaining. And you can rest in that, not just tonight, but always. The knowledge that the largest processes of existence are not your responsibility to maintain. If any part of tonight's story made you feel something soft or wide or curious, leave a comment below. We read them all, and they remind us why we do this. Your words matter here. The rotation of the earth also gives us something we think about rarely, but depend on completely. The magnetic field. Deep inside the earth, liquid iron in the outer core moves and circulates, driven by heat from the inner core and affected by the planet's rotation. This circulating iron generates electric currents, and those currents generate a magnetic field that extends far out into space around the planet. This is called the magnetosphere, and it is one of the most important invisible structures in your life. It deflects charged particles from the sun, the solar wind, that would otherwise strip away the atmosphere and make this surface uninhabitable. The magnetosphere is a kind of shield, and it has been protecting life on Earth for billions of years. The Earth's magnetic field also gives us the aurora, those great curtains of light that appear in the polar skies, green and violet and white, and sometimes red, when charged particles from the sun spiral down along the magnetic field lines and collide with the upper atmosphere. The aurora is one of the most beautiful things the planet makes, a gift from the interaction between the sun and the Earth's own deep motion. You cannot feel the magnetic field, you cannot see it directly, but birds can sense it. Many species navigate by it, using the Earth's magnetic field as an internal compass. Some bacteria align themselves with it. Even your own body has trace amounts of magnetite, a magnetic mineral, in certain tissues, though whether this plays any role in human perception is still a question scientists are quietly investigating. There is a map of the world that almost no one ever sees, but that is always present. A map of where the magnetic poles are and where they are not. The geographic North Pole and the magnetic North Pole are different places, and the magnetic pole moves over time. It has drifted hundreds of kilometers in the past century, and it moves in ways that geologists are still working to understand. The magnetic field has also reversed many times in Earth's history. The North Pole becoming the South Pole and back again, leaving a record in the magnetized rock of ancient seafloors like the pages of a very old, very slow book. All of this, the moving core, the magnetic shield, the aurora, the migrating poles, is connected to the same rotation you cannot feel. It is all one system. The spin of the planet reaches inward to the molten iron at its heart and outward to the shimmering lights at its poles. And it passes through your stillness without a trace. As you breathe now, let the world be as large as it is. You do not need to shrink it to feel safe in it. The largeness is part of what is holding you. Scientists have found some of the oldest rocks on Earth in Western Australia, formations that are over 4 billion years old. These rocks have been part of the Earth since before the oceans settled into their current shapes, before the continents wandered into anything like their present positions, before any life more complex than single-celled organisms existed on the surface. They have traveled over billions of years across climates and latitudes and geological eras. And tonight, they are resting in a museum case somewhere, still and quiet, their journey invisible in their silence. If those rocks could tell the story of where they have been, it would take longer to hear than any human civilization has yet existed. You are a part of the same story, just a shorter chapter. Your atoms have been part of other things, other bodies, other places, other form, and they will be part of other things again after you. But right now, in this moment, they are arranged in the specific, temporary, beautiful configuration. That is you. They are resting. The spin of the earth is carrying them, and the universe has arranged itself so that all of this motion feels, from where you are, like perfect stillness. Let us wander now into the world of shadows. Every day, as the earth turns, the shadow of night sweeps around the globe in a slow, enormous arc. This shadow, the region of the planet temporarily turned away from the sun, moves at the same speed as the Earth's rotation, roughly 1,670 kilometers per hour at the equator. If you could watch from space, you would see this great dark wave rolling continuously around the planet, never stopping, never faltering, following the curve of the world as faithfully as any tide. And as it passes over you each evening, it brings the temperature down, the stars out, and a quiet so particular it seems to have its own texture. The shadow of the earth is not emptiness. It is a presence, a vast, cool, unhurried thing that has been visiting every part of this world since before life existed to notice it. Shadows have been one of our oldest tools for understanding the Earth's motion. Ancient Greek thinkers noticed that the shadow the Earth cast on the moon during a lunar eclipse was always circular, regardless of the angle. A flat object would cast a flat shadow in some orientations. Only a sphere, they reasoned, would always cast a circular shadow. This was one of the earliest geometric proofs that the Earth was round, arrived at not by sailing around the world, but by watching the shape of a shadow on the moon. The sky, then as now, was a kind of mirror, reflecting back the shape of the world we were standing on. Eratosthenes, a librarian and mathematician in ancient Egypt, took this further. He knew that at noon on the summer solstice, the sun shone directly into a deep well in the city of Syene, reflecting off the water at the bottom, which meant the sun was directly overhead. But in Alexandria, several hundred kilometers to the north, a vertical stick cast a small but measurable shadow at the same moment. He measured the angle of that shadow, calculated what fraction of a circle it represented, and from there calculated the circumference of the Earth. He arrived at a figure astonishingly close to the one we use today. All of this from a stick and a shadow, 2,000 years before any satellite confirmed it. The Earth's shape, its size, the geometry of its relationship with the sun, all of it was readable in the slow, patient movement of light and dark across a sundial. There is something deeply peaceful about this. The answers were always there, written in shadow on the ground. The world was always willing to explain itself to anyone patient enough to watch. If you're finding tonight's journey soothing, we'd love it if you left a like. It helps more people discover this little corner of the night. And our playlist has many more quiet evenings waiting for you whenever you're ready. As you lie here, consider the idea of a day. It seems simple. The sun rises, the sun sets, and the span between is called a day. But there are actually two different kinds of day, and they differ by just a few minutes, in a way that has shaped calendars and clocks for thousands of years. The first kind is the solar day, the time it takes for the sun to return to the same position in the sky, noon to noon, or sunrise to the next sunrise. This is 24 hours. But there is also the sidereal day, the time it takes the Earth to rotate exactly once relative to the distant stars. And this is about 23 hours, 56 minutes, and 4 seconds. Nearly 4 minutes shorter than the solar day. The reason for the difference is beautiful. As the Earth rotates, it is also moving along its orbit around the sun. After one full rotation relative to the stars, the Earth has also moved a little further along its orbit. And so, it needs to rotate a tiny bit more to bring the sun back to the same position in the sky. That extra rotation takes almost 4 minutes. Over a year, these 4 minutes accumulate into a full extra rotation, which is why, if you track the stars carefully over 12 months, they will have appeared to rotate 366 times across your sky, even though the sun has only risen 365 times. The Earth makes one extra turn each year, quietly, without announcement, in service of keeping the stars in their right places. This means that each night, the stars rise about 4 minutes earlier than they did the night before. Over weeks and months, this shifts the constellations visibly. What was overhead at midnight in summer is setting in the west by autumn and has vanished below the horizon by winter. The sky is a seasonal thing, turning slowly, offering different stars to different times of year, so that ancient people could read the sky like a calendar and know when to plant, when to harvest, when to expect the rains. All of this subtle, exquisite timing, all flowing from the 4-minute difference between a solar and a sidereal day, which is itself a consequence of a planet in motion around a star. There are places on Earth where the sun barely sets in summer. At high latitudes, in Scandinavia, in Iceland, in the far north of Canada, in the parts of Russia that lean toward the Arctic. The summer sun dips below the horizon only briefly, or sometimes not at all. The sky stays pale and luminous, a kind of perpetual twilight that can last for weeks. This is the midnight sun, and it happens because the Earth's axis is tilted, not straight up and down relative to its orbit, but leaning at about 23.5 degrees. In summer, one pole is tilted toward the sun, and the regions near that pole never fully rotate into shadow. In winter, the same regions tilt away, and the sun barely climbs above the horizon at all. The long polar night sets in, and the darkness becomes its own kind of landscape. This tilt, 23.5 degrees, is the source of all seasons. Without it, the Earth would receive almost the same amount of sunlight at every latitude all year round, and there would be no spring, no autumn, no winter darkness, no summer abundance. Every ecosystem on Earth has evolved in response to the seasons that this tilt creates. The deciduous trees that drop their leaves, the animals that hibernate, the birds that migrate. All of them are living in relationship with a 23.5 degree lean that has been the same for billions of years. A lean you cannot feel, a lean that shapes everything. Let your body settle even further now. Your weight against the surface beneath you is the product of that lean, those seasons, all of that quiet, tilted history. Something else lives in the tilt. The solstices and equinoxes, 4 gentle turning points of the year. At the equinoxes, one in March, one in September, the Earth's tilt is sideways relative to the sun, and day and night are almost exactly equal everywhere on the planet. The word equinox comes from the Latin for equal night. At the solstices, one in June, one in December, the tilt is most directly toward or away from the sun, giving one hemisphere its longest day and the other its shortest. These 4 points in the year have been celebrated by almost every human culture across every continent and era, because they mark the turning of a rhythm so ancient and reliable that it became the foundation of agriculture, religion, and the measurement of time itself. The solstice fire, the midsummer festival, the midwinter feast, all of them, in their different ways, are celebrations of a planet moving through its orbit in perfect, predictable fidelity. If you've been listening to these stories for a while, we'd love to hear from you in the comments. What topics make you drift off the most gently? We read everything, and your ideas shape future evenings here. The word planet itself comes from the Greek word for wanderer. The ancient Greeks noticed that most stars stay in the same positions relative to each other, night after night, year after year. But a few bright points of light moved against that backdrop, tracing slow paths across the constellations over weeks and months. These wanderers, what we now call Mercury, Venus, Mars, Jupiter, and Saturn, seemed to follow rules that were both regular and puzzling. Sometimes they moved from west to east. Sometimes they appeared to stop and reverse direction, moving east to west for a while before turning around again. This backward motion, what astronomers call retrograde motion, confused thinkers for centuries because it seemed to suggest that the planets were somehow spiraling or looping through the sky. The explanation, once Copernicus and Kepler and Galileo worked it through, is entirely a matter of relative motion. When the Earth, moving in its faster inner orbit, overtakes an outer planet like Mars. The perspective from Earth makes Mars appear to move backward, the same effect as when you pass a slower car on a highway, and the other car seems, briefly, to be moving backward relative to you. It is not Mars that reverses. It is the geometry of two bodies in different orbits, moving at different speeds, creating an apparent reversal that is entirely a trick of perspective. Once you understand this, the night sky stops being a mystery and becomes something even better, a demonstration visible to the naked eye of planets moving in their faithful paths around the sun. And all of this apparent wandering, this retrograde dance, happens because of motion you cannot feel. The Earth sweeping through its orbit at 29.8 kilometers per second, overtaking its neighbors, changing the angle at which we see them. All of it invisible to the body, visible only in the slow drift of light across the dark. There is a place in the solar system called the asteroid belt, a wide region between Mars and Jupiter where millions of rocky bodies orbit the sun in a great diffuse ring. Some of these are tiny, no bigger than a house. The largest, a dwarf planet called Ceres, is about 940 kilometers across, smaller than the Moon, but large enough that its own gravity has pulled it into a roughly spherical shape. The asteroid belt is often depicted in films as a dense, chaotic field where spacecraft have to dodge tumbling rocks. But the real belt is mostly empty space. If you were to fly a spacecraft through it, the chances of coming within 1,000 kilometers of any asteroid would be quite small. The rocks are there, millions of them, but the belt is so vast that even together they amount to less than 4% of the mass of the Moon. It is a region of quiet, not chaos, a slow, ancient orbital dance, every rock making its patient circuit of the sun in its own time. Some of these asteroids stray from their paths, nudged by the gravity of Jupiter or Mars, and occasionally one finds its way toward the inner solar system, toward the Earth. Most burn up in the atmosphere, giving us the streaks of light we call meteors, falling stars, though they are not stars at all. When conditions are right, and the Earth passes through a trail of debris left by a comet, we get meteor showers, dozens or hundreds of meteors per hour, all appearing to radiate from a single point in the sky, like the spokes of a wheel. The Perseid shower in August, the Leonids in November, the Geminids in December, each one named for the constellation from which its meteors seem to stream. Each one a product of the Earth moving through its orbit, sweeping up ancient debris left by ancient travelers. You can watch meteor showers from your backyard on a clear night, lying on a blanket and looking up. No telescope needed, just time and stillness and a dark sky. The meteors will come at their own pace, some faint, some bright, some leaving brief glowing trails that linger for a second before dissolving. Each one is a small piece of something old, older than Earth, older than the solar system's current shape, making its final, bright, brief appearance before joining the world below. Let your breathing slow a little more now. There is nothing to watch tonight except the inside of your closed eyes. Everything is very quiet. The Earth is moving through space at 30 kilometers per second, and all you can feel is the softness of the place where you are resting. Something to know about the Moon that is easy to overlook. We always see the same face. From Earth, one side of the moon is always visible. The familiar face with its dark seas and bright highlands that people across the world have turned into stories and shapes for as long as there have been eyes to see. The far side of the moon, once called the dark side, though it is not actually darker, was never visible from Earth until a spacecraft photographed it in 1959. This is not an accident of position. It is a consequence of tidal locking, the same gravitational interaction between the Earth and the moon that creates ocean tides has also, over billions of years, slowed the moon's rotation until it exactly matches its orbital period. The moon rotates once on its axis for every time it orbits the Earth, and the result is that the same hemisphere always faces us. Many of the solar system's moons are tidally locked to their planets in the same way. Io, Europa, Ganymede, and Callisto, the four great moons of Jupiter, all keep one face toward Jupiter. The large moons of Saturn do the same. It is a natural outcome of long gravitational relationships, the orbiting body gradually surrendering its independent spin to the rhythm of the larger body it circles. In a sense, the moon and the Earth are dancing, a slow, synchronized waltz that has been going on for 4 billion years. And like all good dancing, once you find the rhythm, you stop feeling the steps. You just move. If this is the kind of thing that helps your mind quiet down at the end of the day, please do share the channel with someone you think might enjoy it, or drop a comment below. Those small gestures mean so much, and they help keep this space going. Water is endlessly patient. It finds its way into the lowest places, wears away the hardest rock, fills every vessel it is poured into, and takes its shape exactly. And water across the surface of the Earth is also in constant motion. Not just the tides we have already spoken of, but deep currents that move through the ocean like slow rivers, covering enormous distances at speeds almost too glacial to imagine. The thermohaline circulation, sometimes called the ocean conveyor belt, is a global system of deep currents driven by differences in the temperature and salinity of seawater. Cold, salty water near the poles sinks because it is denser and moves slowly along the ocean floor toward the equator and beyond. Warm surface water flows in to replace it, and this circulation carries heat from the tropics toward the poles and cold from the poles toward the tropics, moderating the climate of the entire planet. This global conveyor belt takes about 1,000 years to complete one full circuit. A drop of water entering the deep ocean near Greenland today might take a millennium to travel through the abyssal plains and rise again, warmed in the Pacific. The water in your glass might have been part of this circulation cycle multiple times over the course of Earth's history. It might have rested on the floor of the Atlantic in darkness and cold, while civilizations rose and fell above it on the surface. Water has a memory that makes our own histories feel brief. The thermohaline circulation keeps Western Europe surprisingly mild for its latitude. London is at the same latitude as parts of Canada where the winters are extreme. But the Gulf Stream, the warm current that flows north along the American coast and then across the Atlantic, keeps European winters relatively gentle. The ocean is not just the backdrop to human civilization. It is an active participant, distributing warmth and cold across the globe in a pattern so slow it seems like stillness, but is in fact a planet-wide process of thermal regulation, running quietly beneath every ship, beneath every wave, beneath every rainstorm that has ever reached the shore. Glaciers are also in motion, so slowly that measuring their movement requires instruments, not eyes. A glacier moves by flowing, the weight of the ice above pressing the lower layers into a kind of slow plastic creep, sometimes just centimeters a day, sometimes a meter or more. Where the glacier meets the sea or a lake, great chunks break off in a process called calving, falling into the water with sounds like thunder before settling into quieter shapes as icebergs. An iceberg drifts with the currents for months or years, melting slowly, carrying fresh water from the high snowfields of a glacier's origin, hundreds or thousands of kilometers from where the ice first fell as snow. The oldest ice in Antarctica contains air bubbles trapped when it was snow, bubbles that hold samples of the atmosphere from hundreds of thousands of years ago. Scientists drill down into this ancient ice and extract cores, reading the chemical signatures of the air inside like the rings of a very old tree. They can tell what the atmosphere was like during past ice ages, what the temperature was, how much carbon dioxide was present. The ice remembers. In the deep cold of the polar ice sheets, time has been stored rather than passing. A long, cold archive of the world's atmospheric history, waiting in the dark. Let the cold of that deep ice be only an idea tonight, not a sensation. You are warm. You are held. The planet is taking care of its accounting in the deep places, and you do not need to worry about any of it. Sound travels differently, depending on what it is moving through. In air, at sea level and room temperature, sound travels at about 343 meters per second, fast enough to cross a football field in about 1/3 of a second. In water, sound travels about 4.5 times faster, because water is denser and less compressible. In solid rock, it can travel even faster, several kilometers per second, depending on the type of rock. This is why earthquakes produce waves that travel through the interior of the earth. The seismic waves generated by the movement of tectonic plates spread outward through the rock in all directions, both along the surface and through the deep interior. Seismometers, the instruments that detect these waves, can pick up earthquakes on the other side of the planet, because the waves have traveled all the way through the Earth's interior to reach them. And here is something remarkable. By studying how seismic waves travel through the Earth, which paths they take, how fast, how they change direction or speed or disappear at certain boundaries, scientists have been able to map the interior of the Earth without ever visiting it. The waves bend when they enter a denser medium, the same way light bends when it enters water. Certain waves cannot travel through liquid, and they vanish when they reach the liquid outer core, leaving a shadow zone on the other side. By mapping these shadow zones, scientists determined that the outer core is liquid, even though no one had ever seen it. The inside of the Earth was read from the outside by listening to the planet's own voice. The Earth is always speaking. It is always sending seismic waves outward from the countless small earthquakes and tremors that happen every day. Most of these are too faint to feel. There are roughly 500,000 detectable earthquakes per year worldwide, but only a small fraction of those are strong enough to be noticed without instruments. The planet is in constant, gentle conversation with itself, and the listening devices we have built to hear that conversation have given us a picture of the Earth's interior more detailed than many maps of the surface. Please do like this video if you're still here and still drifting. It's a small thing that makes a large difference to whether others can find their way to evenings like this one. There are sounds you have never heard and never will, not because they are too distant, but because they are too slow. Infrasound is sound with frequencies below what human ears can detect, below about 20 cycles per second. Some animals can hear it. Elephants communicate in infrasound across distances of many kilometers, their calls carrying through the ground as well as the air. Whales produce infrasound that can travel across entire ocean basins. Certain birds can sense the infrasound generated by distant storms, helping them navigate and find shelter before the storm arrives. The atmosphere generates infrasound constantly, through thunderstorms, through ocean waves, through the movement of mountain ranges in the wind. The earth is full of sound below our hearing, a deep, slow music that the animal world is tuned to in ways we are only beginning to understand. There is also ultrasound, sound above the upper limit of human hearing, above about 20,000 cycles per second. Bats use it to navigate in the dark, emitting pulses of ultrasound and listening to the echoes that bounce back from objects and prey. The time it takes for the echo to return tells the bat exactly how far away the object is. Dolphins use a similar system underwater, sending out clicks and receiving the returning echoes with remarkable precision, enough to detect a fish-sized object at a distance of dozens of meters, even in murky water. This biological sonar, called echolocation, is one of the most sophisticated sensory systems in the animal kingdom, and it operates entirely in a region of sound that is invisible to us, as silent as the rotation of the earth. What a strange gift it is to be one particular kind of sensing creature among so many. You are tuned to a very specific slice of the possible, the frequencies of light that make up what you call color, the frequencies of sound that make up what you call noise. Outside those windows, the world is full of other information, the ultraviolet colors that bees and birds see in flowers, the magnetic fields that birds navigate by, the electric fields that some fish use to sense the world around them, the infrasound of distant storms, the ultrasound of the hunting bat. You are not limited by being unable to sense these things. You are simply one particular shape of awareness, beautiful and specific, moving through a world richer than any one sense can hold. And even with the senses you have, there is more than enough to wonder at. The way a piece of music can move through you, the way cold water feels on a hot afternoon, the smell of rain on dry earth, petrichor it is called, from the Greek words for stone, and the fluid that flows in the veins of the gods. The smell is produced by a compound called geosmin, released by certain bacteria in the soil when rainwater disturbs them. You smell the life in the ground. You smell the earth waking up. And all of it, all these sensations and perceptions and quiet wonders, arrive through a body that is hurtling through space and cannot feel any of it. There is a quiet miracle in every moment of ordinary experience. Rest in that for a while. Let us think about light, because light is the thing that most connects you to the universe, and it has its own slow, astonishing story to tell. The light reaching your window on a clear day left the sun about 8 minutes ago. 8 minutes ago, it was still inside the corona of the sun, or just past it, beginning its journey across 150 million kilometers of mostly empty space. In those 8 minutes, you might have made a cup of tea. The light traveled from the sun to you, and when it arrives, it carries energy that powers every living thing on Earth, the entire food web resting ultimately on the transaction between sunlight and green leaves. But before that light could leave the sun, it had a much longer journey. The energy in sunlight is generated in the sun's core, in the nuclear reactions that fuse hydrogen into helium. But the core is so dense that the light, or more precisely the photons produced by those reactions, cannot travel in straight lines. They are absorbed and re-emitted, absorbed and re-emitted by the dense plasma of the solar interior billions of times over. This random walk from the core to the surface takes, on average, about 100,000 years. The light that warms you today began its journey as nuclear energy in the core of the sun before Homo sapiens existed. It took 100,000 years to wander from the core to the surface, and then 8 minutes to cross the space between the sun and you. 100 millennia of wandering, and then 8 minutes of flying. And then a moment on your face on a quiet afternoon as the earth turned and held you in the light. If you ever wake in the night and cannot sleep, and your thoughts feel too loud, know that you can always find us in the playlist. There are many evenings here, many quiet topics, all told in this same slow way. We'll be waiting. Consider the atmosphere you breathe. It is about 78% nitrogen and 21% oxygen, with small amounts of argon, carbon dioxide, water vapor, and traces of other gases. This mixture is not accidental. It is the product of billions of years of chemistry, biology, and geology. Early in Earth's history, the atmosphere was very different, mostly carbon dioxide, nitrogen, and water vapor, with almost no oxygen at all. The oxygen in the air today was produced by living things, by the photosynthetic bacteria called cyanobacteria, which first appeared about 2.7 billion years ago and began producing oxygen as a byproduct of turning sunlight into energy. Over hundreds of millions of years, oxygen accumulated in the atmosphere, transforming the planet and making possible the kind of complex, energy-intensive life that eventually produced you. The transition to an oxygen-rich atmosphere, sometimes called the Great Oxidation Event, was, for the life of the time, something of a catastrophe. To organisms that had evolved in an oxygen-free world, oxygen was toxic. Many species went extinct or retreated to environments where oxygen couldn't reach them. Deep sediments, oxygen-poor waters, the insides of other organisms. But the organisms that survived or evolved to use oxygen gained access to a metabolic pathway, aerobic respiration, that is far more efficient than the older methods. The energy available to them increased dramatically. And from that expanded energy budget, over long spans of time, complexity increased. More sophisticated cells, then multicellular organisms, then the enormous variety of animal life that would eventually populate the seas and land and air. Every breath you take is a gift from life that lived billions of years ago. Every inhale draws in oxygen produced by the slow, patient labor of microscopic organisms that never knew a world with animals in it. And the nitrogen that makes up most of each breath passes through you unchanged, neither used nor harmed, just present. a legacy of a world that preceded oxygen. The air is not just a resource, it is a history. Let your breath come and go now, without effort. The air knows what it is doing. It has been doing this for a very long time. We have talked across these evenings about many forms of motion: the spinning of the earth, the orbiting of planets, the drifting of continents, the flow of ocean currents, the wandering of photons through the sun. But there is one more kind of motion worth settling with before sleep: the motion of thoughts. Thoughts are not still. They arrive and they pass. They rise like bubbles from somewhere below and dissolve before you can quite catch them. They build and shift and recombine. And the brain that produces them, that 3-pound structure resting in the dark of your skull, is itself constantly in motion. Electrical signals moving between neurons at speeds of up to 120 meters per second, chemical messengers crossing the tiny gaps between cells, the slow cycling of sleep states that we are just beginning to understand. During sleep, the brain does things it cannot do while awake. Cerebrospinal fluid, the clear liquid that cushions the brain and spinal cord, pulses through the brain's tissues in waves during sleep, washing away the metabolic waste products that accumulate during the day's thinking. This cleaning process, called the glymphatic system, works most efficiently during sleep, particularly during the deep, slow-wave sleep of the early night. The brain is literally tidying itself while you rest. The clearing of waste, the consolidation of memories, the processing of the day's emotional experiences, all of it happens in the hours when you are no longer aware of it. Sleep is not the absence of brain activity. It is a different kind of activity, one that the brain has been doing for as long as brains have existed. Every vertebrate animal sleeps in some form. Fish sleep. Insects sleep. Even some invertebrates show periods of reduced activity and responsiveness that appear to function like sleep. It is one of the oldest behaviors in the animal kingdom, and its function, while still not completely understood in every detail, is clearly essential. An animal deprived of sleep for long enough will die. Sleep is as necessary as food, as necessary as water, and the brain that seems to rest during sleep is, in its own way, working harder than ever, maintaining, repairing, consolidating, dreaming. Leave us a comment tonight if you'd like, before you drift completely away. Even a single word, whatever comes to mind. We love knowing you're here and knowing where in the world you're resting as you listen. And so, we arrive at last at the place where science and sleep become the same thing. The questions that science asks: what is this? How does it work? Why does it happen? Where did it come from? Are the same questions the mind asks in its quiet moments, lying in the dark, listening to the breath. Science is not a set of answers. It is a way of staying curious. It is the practice of wondering without needing to resolve the wonder, of sitting with a question and letting it open rather than close. The earth is spinning right now. It has been spinning for 4.5 billion years, and it will go on spinning for billions more, until the sun, in its old age, expands into a red giant and swallows the inner planets. And even then, the atoms that made up the earth will not stop moving. They will disperse into the interstellar medium, the vast cloud of gas and dust between the stars, and they will drift, and some of them will eventually be gathered up by new gravitational collapse into new stars, new planets, new possibilities. Nothing ends. It only transforms. The atoms in your body have been through stars before this sun. They will be through stars again after. You are, in the most literal physical sense, a temporary arrangement of matter that has been many things and will be many more. This is not a reason for anxiety. It is a reason for a very particular kind of peace, the peace that comes from being a small part of something enormous and ongoing. You did not have to make yourself. You did not have to build the laws of physics that hold you together, or the planet that supports you, or the star that warms you. All of that was already here, waiting. And all you have to do tonight is rest. Let the earth turn. Let the atmosphere breathe above you. Let the currents move in the deep dark of the ocean. Let the stars drift in their slow arcs across the sky. Let the neurons fire and quiet. Let the glymphatic system do its patient work. You are exactly where you need to be, in motion and still, enormous and small, ancient and new. The planet is spinning. The universe is expanding. And you are here in the middle of it all, just resting. There is nowhere else to go. There is nothing else to do. The science of this moment, the physics, the biology, the astronomy, the geology, all of it comes down to this. You are safe. You are held. The world is very old and very large, and it has been carrying living things in a silence so complete that none of them has ever felt the speed. Close your eyes now, if they are not already closed. Let the darkness be soft. Let the thoughts come and go like the tide that you cannot feel, moving the solid rock beneath you. Let the breathing slow to something even gentler, the way the ocean slows in the deep water far below the surface, where there are no waves, only pressure, only the slow drift of currents, older than any map the sleepy science channel thanks you for being here tonight. Sweet dreams. Rest well. The earth will take care of the traveling.